So today we're saying hello to CUDA. We're going to work on the basic components of CUDA. We're going to write a HelloCuda program. We're going to work on summing to arrays, and we're going to wrap it up with more theoretical aspects. And here we go. So now we're going to focus on HelloCuda basics. CUDA C is an extension to the popular C programming language, namely NCC. To a CUDA programmer, the computing system consists of a host that is the traditional CPU, and one or more devices that are processors with a massive number of arithmetic units. A CUDA device is typically a GPU. So now we work on the CUDA program structure. The structure reflects the coexistence of a host, a central processing unit, CPU, and one or more devices, namely GPUs, in the computer. Any traditional C program is a CUDA program that only contains host code, meaning code that can only be run in a CPU. If we add device functions to a traditional C script, we can no longer use a traditional C compiler. The addition of device functions requires the use of the NVIDIA CUDA compiler, which is abbreviated to MVCC, NVIDIA CUDA compiler. The host code is always MVCC, whereas the device code is marked CUDA keywords for labeling beta parallel functions called kernels and their associated beta structures. Further, the device code is further compiled by a runtime component of NVCC and executed on a GPU device. The integrated C programs of CUDA extensions work as the diagram below shows. The integrated C programs with CUDA extensions go through NVIDIA CUDA compiler. Host code follows the NCC preprocessing, compiling, and linking, and then goes through a heterogeneous computing platform with CPUs and GPUs. The same goes for the device code. The device code goes, however, there's a difference. The device code goes to the device just-in-time compiler, and afterwards it goes to the heterogeneous computing platform with CPUs and GPUs. Now we move to kernel function calls. The execution starts with host CPU execution. When a kernel function is called from the host code, it is executed by a large number of threads on a GPU device. All threads that are generated by a kernel launch are collectively called a grid. Succinctly, a thread is a simplified image of how a processor executes a program in modern computers. In CPUs, the execution of a thread is sequential as far as the user is concerned. The launch of a kernel typically generates a large number of threads to exploit beta parallelism when it is possible to parallelize an algorithm. We can have cases in which the number of threads that will be generated are equal to the size of an array/vector. CUDA programmers can assume that these threads take very few clock cycles to generate and schedule due to efficient hardware support. Design specifications. So the central processing unit is designed to handle a wide variety of tasks, such as running the operating systems, executing execution programs, and performing complex calculations. The CPU typically has a small number of cores which are optimized for sequential execution of instructions, and large cache memory to hold frequently used data. On the other hand, graphics processing units, also known as GPUs, are designed to handle large amounts of data in parallel. A GPU has a large number of cores which are optimized for executing the same instruction on multiple pieces of data in parallel. GPUs also have a large amounting memory called VRAM, video RAM, that holds data that the cores are working on. Sequential execution is better for CPUs, meaning that you want to use a CPU if the program is not parallelizable. Now, parallel execution is better for GPUs, meaning that you want to use it if the task is repeated often for different memory addresses, meaning that it can be parallelized. Here is a simple HelloCuda program. The global keyword indicates that this program is going to run on the device. However, there's not all the components that we're going to have to program, so we're moving on to Golang. So now we're just going to do a vector addition kernel. It's just a traditional C program that consists of a main function and a vector addition kernel. So part one is moving host memory to device memory GPU part two. And once we finalize the operations on the device, we move on to part three, which is basically transferring the data and the GPU memory back to host, where we can print the results in our Google Colab stream. Device, global memory, and data transfer. Now, to execute a kernel, you have to allocate global memory. On the device, transfer pertinent data from the host memory to the allocated device memory. After the device execution, all resultant data or a selected portion of modified data from device memory has to be transferred to host memory. Subsequently, the host memory that is no longer in use has to be freed. Below are the functions from the application programming interface of the CUDA runtime that will help us transfer data between the device and the host. The CUDA malloc function allocates an object in the device global memory. This might be a primitive or a struct and have design. This function has two parameters, the address of a pointer and the size of the allocated objects in bytes. The CUDA memcqi function performs the memory beta transfer It has 4 parameters. It has a pointer to destination, a pointer to the source, a number of bytes copied, and the direction of transfer, meaning that we can choose to transfer from host to device, and then from device to host, which is the usual order of operations. Now, CUDA free. We free the object from device global memory. We have a pointer to the freed objects. Now, the CUDA device synchronize function. This function blobs until the device finishes all of the preceding tasks. This function returns an error if one of the preceding tasks failed. So, thanks for watching this video. First of all, this video was made using the speech-to-speech converter from leavenlabs.io. By no means did I speak British English. I wish I had a British accent. I have a horrible British accent in real life. You'll see in future videos. And please check out the link below it. And that'll be it.